As mentioned in the previous tutorial, we have three subdivisions of structural isomers, which are positional isomers, functionally group isomers, and chain isomers. Let's start with positional isomers. In positional isomers, the functionally group, which will be the same, is attached to the main chain at different points. For example, the molecular formula C3H7Cl could represent 1-chloropropane or 2-chloropropane. So the molecular formula of both compounds is C3H7Cl. However, this chlorine atom, which is the functional group, these two compounds are halogen alkanes. So the chlorine atom is attached at two different positions. So these are positional isomers because the position of the same functional group on the same main chain is different. So in this case, it is attached to carbon number 1, whereas here it is attached to carbon number 2. Let's talk now about functional group isomers. So one subdivision of structural isomers is functional group isomers, where we have different functional groups. So we will have the same molecular formula, however, the functional group will be different. For example, we have this molecular formula C2H6O, which could be ethanol. So we have 2 carbon atoms, 6 hydrogen atoms, and 1 oxygen atom. And this is an alcohol, so the OH group represents alcohols. Or we may have methoxymethane, which is an ether. So we have 2 carbon atoms, 6 hydrogen atoms, and 1 oxygen atom. This is the functional group, the oxygen atom. So this is an ether. So we have the same molecular formula, however, totally different functional groups. These are called functional group isomers. And finally, we have chain isomers. In chain isomers, we will have a different arrangement of the hydrocarbon chain. So if we take the molecular formula C4H9OH, it could be butane 1-ol, so it is an alcohol with the OH group attached to the first carbon atom in the chain, or it could be 2-methylpropane 1-ol. So in this case, the main chain has 4 carbon atoms, whereas in this compound, the main chain has 3 carbon atoms, and the 4th carbon atom is a branch, so it is a sided chain. So we have the same functional group, however, the arrangement of the atoms in the main hydrocarbon chain is different. And in this case, it is most likely to have branches. The existence of isomers makes the task of identifying an unknown organic compound more difficult, because usually when we have an unknown organic compound, we will identify its molecular formula. However, even if we identify the molecular formula, we are not able to identify the structural formula and to specify which isomer is this compound. And in this case, we have to use analytical methods which tell us about the structure.